Okay, welcome everyone to the keynote lecture by Olivier Coibion. We're really delighted to have Ollie with us, and I'm delighted to be able to introduce him as our keynote speaker this morning. So Ollie is the Professor of Economics at the University of Texas, Austin. Before that, he worked at the IMF, the Council of Economic Advisors, the Brookings Institution, and the College of William and Mary. He holds a BA in Economics and Political Economy from Berkeley and a PhD from Michigan. He's a leading researcher in the use of survey data to understand monetary policy, and his contributions lie in explaining how households and firms form their expectations, how they respond to signals of inflation and to uncertainty. His latest publication in Econometrica is a good example. It's called Tell Me Something I Don't Already Know, Learning in Low and High Inflation Settings, and explores the interaction between the economic environment and the learning process for inflation. He's worked for a long time with his longtime co-author Yuri Rodnichenko on very well-known topics and in this area, and appears in the top 5 top field journals across economics. And appropriately, they've both written a new book called Expectations Matter, the new causal macroeconomics of surveys and experiments, which is forthcoming in Princeton University Press. This work summarizes much of the work they've published together over the last decade and is the topic of this keynote address. The central theme is how RCT experiments, familiar in medicine and pharmacology, can be used in economics to examine the causal impact of expectations. This is extremely important for policymakers, especially monetary policymakers. And that means we're all beneficiaries of Ollie's research, since it contributes to better understanding of the transmission mechanism and therefore to better monetary policy making. Ollie, we're looking forward to your lecture and hearing what you have to say. Let me hand over to you. The floor is yours, and we'll take questions at the end.
Great. Thank you very much, Paul, for the introduction. Thank you very much for having me here. Thank you for coming. So as he said, Yuri and I wrote this book recently. We were told by the publisher we have to advertise it, so this is my advertisement for it. I told the publisher, but if we present it to people, then no one's going to buy it. They said no, you have to present anyway. So here it is. The basic idea is, in most macroeconomic decisions, the optimal behavior is forward-looking, right? So how much do we want to consume or save today depends on our expectations of our future income, future prices, etc. What price a firm will set today depends on their expectations of the future. So throughout macro, we have these theoretical predictions that the optimal decisions our agents are going to take should depend on their expectations of the future. And so we, like to assess to what extent this is true. And policymakers frequently, refer to this forward-looking behavior in discussing how they're going to set policy and the extent to which this matters to them. So here's an example from Powell recently talking about the extent to which they think tariffs will affect inflation, et cetera, and the extent to which they feel the need to respond to these shocks is going to depend on how expectations are expected to respond. Now, the question is, how do we characterize, test the actual role played by expectations in economic decision making? So in principle, there's a few different ways we can do this using our standard macro tools, right? So strategy one would be, well, let's write down standard macro model. That macro model is going to embody some forward-looking behavior, right? And then we can go out, estimate the model and see how well it does, right? And that's going to give us implicitly a test of the mechanisms of the model, including the forward-looking behavior. Right? Now, of course, it's going to combine all the different mechanisms that are at work in the model. So if the model fares poorly along some dimension, it's not going to tell us, is it the expectations, the forward-looking behavior that's not right, is it something else? But this is one strategy we can pursue. A second kind of very classic approach is, instead of estimating the whole model, we can say, well, let's pick a structural relationship that we think embodies a link between expectations and decisions, right? So for example, a Phillips curve, an expectations augmented Phillips curve is going to relate current inflation to some measure of expected inflation in the real side of the economy, right? Underlying that structural relationship is some mechanism that's linking those expectations to the decisions. So we can try and test that. Third approach is to go to the micro level and say, well, let's look at individuals, let's look at firms, and let's compare their expectations to their decisions and try and test the predictions that we have that way. Right, and there's a lot we can do with the micro data. The biggest issue we'll run into in general is establishing causality, right? Expectations and decisions are both endogenous. How are we supposed to say what's causing what in this setting? And so what I'm going to talk about today is another strategy closely related to the last one, right, which is going to be trying to establish causality so that we can speak very directly to how changes in expectations actually affect economic decisions. That's going to be the goal here. And the way we're going to do it is through RCTs. Okay, so for those of us who were trained in kind of traditional macro methods, the RCT was not part of the toolbox we were taught. It certainly wasn't part of my toolbox. So let me just kind of give you the very bird's eye overview. Right, so you're going to start with a bunch of agents, households, firms, whatever, whose beliefs and decisions you're interested in studying, right? So you're going to go to them, and you're going to first try to measure their initial beliefs. Okay, so usually we're going to have to do this through a survey, right? You start by measuring their prior expectations and ideally also their plans for their future decisions. Okay, so you get a baseline. This is what all these people expect is going to happen to the aggregate economy, to them. This is what they're planning to do. And then once we have all these expectations, then we do the magic of the randomized control trial, right? Which is here going to be just like in a medical study, which is you're going to randomly assign people to different groups, right? And one group is going to get the medicine, and the other group is not going to get the medicine. Okay, the only difference here is that the medicine is going to be a piece of information. Okay, so you're going to have a control group that doesn't get the information, typically, and then a treatment group that gets the information. Right? And the goal is for that information to change the expectations of the treatment group. Right? So you're trying to generate exogenous variation in beliefs through the provision of information. Right? So after you do this, you want to know, was I successful? Did I change anyone's opinion about anything by giving them this information? Okay, so you go back to them, and you want to measure their expectations again so that you can ask the question, did this information treatment actually do anything to their beliefs? So you go back to them and you measure, we'll call the posterior beliefs. Okay. So you can fail at this stage in a lot of different ways, and I'll come back later and I'll talk about some of the many ways in which we can fail already at this first stage. But let's suppose for now that we've succeeded, right? So we've created a change in beliefs for a subset of the agents, right, and left the other agents untouched. right? Ultimately, we want to know, do the expectations affect decisions? And so then what we're going to do is track the decisions of these agents over time so that we can determine whether this exogenous variation expectations that we've created is going to lead to a change in the decisions of these agents relative to the decisions of the untreated ones. Okay, that's it. That's kind of the whole strategy. And so in principle, if it works and you've done it well, right, because of kind of the beauty of the RCT, the randomization, et cetera, right, this is going to be pretty straightforward to check at the end of the day, right? So no fancy econometrics should be necessary here ex post. So let me give you an example where we think things mostly went pretty well. And then I'm going to spend the rest of the time talking about how everything can go wrong. Okay. So this is from a paper that Yuri and I did with Michael Weber, and he followed up on earlier work that Michael did. So what Michael realized is that there's this amazing data set, which is the Nielsen home scan panel, right? So this is a group of households that are scanning all their purchases, right? And so you can observe in a very detailed manner what they purchase, when they purchase it, what price they pay, et cetera, right? So you get all this detailed information. What Michael realized was that you can run surveys of these people. And so if you can do a survey of these people, you can then link it to this incredibly detailed information on their spending. And so he did a paper where he did a survey and he linked the expectations to the decisions. And so what we went back and did later is essentially kind of replicate that approach. Let's survey these households, measure their expectations, but adding in the twist of the RCT. Okay, so another really neat thing about this survey, above and beyond the fact that you can link it to the spending, is the size. So the panel is like 80,000 people. So you send a survey to them, if you get a response rate of around 25%, right, you're going to end up with something like 20,000 people in your survey. Right? For comparison, the New York Fed survey of consumers is something like 1,000, 1,500 people a month. The Michigan survey of consumers, it's like 500 people a month. Right? This is like an order of magnitude larger. Which it turns out, for the strategy I'm going to describe, you actually need this order of magnitude for things to go well. Okay, but so we're going to do this survey. We're going to measure their initial beliefs, right? Their inflation expectations, etc. And then within that survey, we're going to do the RCT. Okay, so it's very simple RCT. We take the households, we split them into several different groups. Actually, there's more treatment groups than what I'm going to talk about, but I'm going to focus on just these ones for today. So one group is the control group that gets no information. And then the other groups I'm going to focus on are these treatment groups that received very simple pieces of information. So one group was told what the most recent inflation rate was in the US, which was just about 2%. One group was told the Fed's inflation target, which was 2%. Another group was told an inflation forecast over the next year, which was basically 2%. Okay, so they're all getting essentially a statement of inflation has been or should be around 2%. Okay, very simple truth. And then after giving them this information, we measure their posterior beliefs. Okay. Now, before I show you what this gives us, let me talk about kind of what you would expect to see. Okay, and let's do kind of expect to see based on a simple Bayesian update. Okay, so the model we have in the back of our minds when we do these RCTs is an agent that starts off with some initial belief, right? That's going to be their prior. They get a piece of information, call that the signal. They form new beliefs, that's the posterior. Right? So simple updating is going to be such that the posterior you form is just a weighted average of your initial belief, your prior, and the information that you get. How much weight you place on that signal is going to be given by the Kalman gain, and it's going to depend on how confident you are in your priors, how precise you think this signal is, etc. Okay, so the way that we're going to assess if the information treatment is successful is by running a very simple regression. Okay, what we're going to do is we're going to look at the cross-section of beliefs. We're going to take everybody's posterior beliefs. So what did they think inflation is going to be at the end of the survey? We're going to regress it on their prior inflation expectation. What did they say at the beginning of the survey? We're going to have an indicator variable for being in the treatment group. And then we're going to have an interaction of your prior belief and this indicator variable for being treated. Okay, so let me explain what this regression should do in principle. All right, so imagine you're in the control group. All right, so if you're in the control group, you did not receive a signal. You gave me a prior initially, you answered some questions. I come back to you and I ask you again, what do you think inflation will be? You give me your posterior. The posterior should be the same as the prior, right? You haven't gotten any new information. There has been no updating. So for the control group, right, where these treatment indicators are 0, when I regress your posterior on your prior, what I should get is alpha equals 0 and beta equals 1. Right? So the control group should nail down these parameters in that way. Now for the treatment group, right, they got a signal. And so what should we be getting in this case? Right? Well, for those agents, again, we're regressing their posteriors on their priors. The slope on the prior, right, should be the 1 minus g, 1 minus the gain. Right? The coefficients we're using are beta plus gamma. If beta is 1, right, then gamma is going to map directly into that gain parameter. So how much weight you're placing on your prior belief here is going to give us the gain. Okay, so intuitively, if I gave you a signal that you thought was irrelevant, and you choose not to place any weight on it, right? The gain should be 0. Your posterior is going to be the same as your prior. You're just like the control group, right? And gamma is going to be 0. Right? If you think the information I provide to you is super informative, you're basically going to put a weight of 1 on the signal and a weight of 0 on your prior. Okay, so that this coefficient will need to be 0, and gamma will just be a -1. Okay, so this is the specification we're going to estimate. So let me show you visually what happens when we do this. All right, so as I said, we're going to be looking at priors and posterior inflation expectations. Okay, so this is a bin scatter of the priors and posteriors for the control group. Right, so what does it say? That says, well, if I go to someone at the start of the survey and they tell me they expect inflation to be 8% over the next year, I ask them a few other questions. I come back to them 10, 15 minutes later and ask them again, what do you think inflation will be on average? They're going to tell me 8%. Okay, which is kind of exactly what you would expect. On average for this group, the posteriors are equal to the priors. Now the slope of the line, you'll notice it's not exactly 1, it's a little less than 1. Right? And this is because we don't actually measure the priors and the posteriors using the exact same questions in these surveys. If there's one thing you can do to really piss people off in a survey, is ask them the same question over and over again. Okay, so we try not to do that. But so what that means is the way that we measure these the priors and the posteriors is through different questions. That's going to introduce some measurement error. That's going to tend to give us slopes that are a little less. But it's not very far from that. Okay, so this is the control group. This looks exactly how we would expect. Okay, now the magical part is what happens with the treatment groups. Okay, so here's that same relationship between the posterior beliefs and the prior beliefs for those 3 treatment groups. Okay, they're different colors and we have different lines, but basically they all have the same effect. Right, so what we get is the regression line is much flatter. Right, so what does that say? That says, you go back to someone who initially thought inflation was going to be 8%. You tell them, hey, the Fed is predicting that inflation will be 2% next year. You go back to them at the end of the survey, you ask them, what do you think inflation will be? And now they're going to tell you 4%. Okay, so they're not going all the way to 2%. They're not going all the way to the information that we provide, right? That would give us a perfectly flat line at the signal. But they're not dismissing the information either, right? They're putting some weight on this information that we're providing. And the fact that these lines are so flat tells us that they're actually putting a lot of weight on the information that we're providing. Okay, so this is a very successful information treatment in the sense of getting people to change their inflation expectations. Okay, so in 2018 Q2, when we did this, right, we're like, oh, this works great. A little bit of information changes these expectations in a very powerful way. Okay, so that's stage 1. Stage 1 of the treatment. By the way, I'm happy to take questions during, if y'all want to ask anything, please. Yes.
You just wait for the microphone. Is there a microphone?
I mean, in the sense of...
Oh, sorry. Microphone.
Thank you. In the sense, you're assuming that people already have an inflation expectation prior to your survey. But isn't it very likely that many people, especially in low inflation countries, don't actually form inflation expectation? They just do so when you ask them in the survey context. And is that really measurement of an existing expectation? Is that not creating an expectation on the spot? Thank you.
I mean, in a general sense, no. You know, people think about prices and they act based on prices. They may not formulate it necessarily in terms of aggregate inflation. But, you know, in the broader sense, that's kind of what we're trying to figure out here, right? Is, are people acting on expectations like inflation expectations in the way that theory would suggest, right? So in our model, people have very well-defined beliefs about what aggregate inflation is going to be. And that expectation translates into their spending decisions, right, via the Euler equation. So you can think of what we're going to do here is we're just going to try and test that kind of mechanism. Right? So, you know, one possible world that we live in is one where those expectations don't even exist and are relevant to people's decisions. Right? So if I go and ask them, what do you think is going to happen to prices? What do you think the inflation rate will be? They're going to throw out a number. They don't know. If I tell them, well, the right number is actually 2%, they're going to change their number something closer to 2%. But it's irrelevant to their decisions, right? That's a possible scenario. That's why we want to get to this next stage of then linking this to their spending decisions. Because here we're going to be able to determine when I've changed this measure of inflation that you report to me, does it actually change your behavior later? Right? Does it pass through into your spending decision? So that's how we can address that question. Right? Because a priori, you're right. It's possible that people really aren't that forward-looking at all. Our models are just completely wrong in assuming that people have this, forward-looking behavior. And here we can test that. Yes.
May I please ask a clarification question on your RCT and the typical RCT in medical studies? Because in typical medical studies, there is a famous placebo effect. So the control group don't know whether they received treatment or not. But in your RCT, because they know they haven't received any information, so they know they are in the control group. So there is no placebo effect at all from the medical RCT perspective. And how would you take that into account in your RCT here? Thank you.
Yeah, so thanks for asking that. So we have a placebo treatment here that I didn't talk about. So we have a separate group that receives a piece of information that's unrelated to inflation, but that has the number 2% in it, and that's our placebo group. So we can essentially assess, if you're just giving someone irrelevant information with that number, is it going to do the same thing as the other treatment groups? And the answer is the placebo treatment, just like people have found in behavioral experiments, it has a little bit of an effect on inflation expectations. So if I kind of go back to this figure, the placebo group is going to be somewhere in between the control group and these information treatment groups. But the effect is pretty small, quantitative. So you can control for that here as well. Yes.
I've been shocked. Does it matter in class what show your forecast or what is inflation percent or your expectation of your basket or your typical basket? How much do you think?
So whether you ask people for the level of aggregate inflation or what's going to happen to their prices or prices in general, it matters a little bit to the levels that you're going to get in the answers. What it's not going to matter for is in the revisions. Okay, so one of the really nice things about the RCTs, and I'll come back and talk about this a little bit later, is, in surveys, you have to always worry a lot about how the question is designed. Survey question design issues are always important and make a difference. But in the RCT, what you end up doing effectively is a diff and diff, right? Because you're going to take this posterior relative to the prior, right? So you're differencing out already one time. And then we're going to look at what's the difference in that difference across the treatment groups. That's the second difference. And so something like, a level effect coming from the way that this question is designed is not going to matter at the end. Not nearly as much as it would if you're just interested in the level. Okay. Okay, so the treatment generates an effect on expectations. Now we want to know, does it do anything to decisions? Okay, so this is the second stage of the RCT. We want to now link this to the decisions of the agents. Okay, so in the Nielsen data, we can observe their spending, some of their spending. We also ran follow-up surveys where we asked them how much they spent on those same categories of goods as what's measured in Nielsen, as well as some broader measures of spending. Okay. Now, once you have these ex post decisions, the way you estimate the pass-through of expectations into decisions is very straightforward, right? You're going to take the ex post outcome, which here is just going to be spending at the individual level some months after the treatment. Right? You're going to regress it on the expectation that you're interested in, which here is going to be the posterior inflation expectation, and then controls. All right, so here we're going to control for your prior beliefs. We're going to control for kind of planned decisions, if your prior plans for what you were going to do, individual controls. Right? And the RCT part kicks in to identify exogenous variation in these beliefs. All right, so what you do is you instrument for the inflation expectations using the treatments. Okay, so the first stage is this kind of ugly looking expression down here, right? But all this is doing is taking your posterior inflation expectation, projecting it on an indicator variable for if you were in the treatment group, and an interaction of that treatment indicator with your prior, which is exactly the figures that I showed you. Okay, so the figures are the first stage. Right? That's what you use to identify exogenous variation expectations. And with that exogenous variation, you can assess to what extent, if at all, does this affect people's spending decisions. Okay. So let me show you what we got using the actual spending that's measured in Nielsen 3 and 6 months later. You know, the first thing to note is, you know, the first stage is very powerful. Okay, so we're in applied micro world in the sense of the information treatment was very powerful in generating exogenous variation in expectations. Okay, so what do we get for spending decisions? What we got is, as people raise their inflation expectations by 1 percentage point, they increase their spending in subsequent months by 1%. Okay, so you have this positive pass-through of inflation expectations into the spending decisions of people ex post. This is spending on non-durables and services. Okay, so the expectations have a causal effect on spending. Now, kind of one interesting thing that came up here is when we looked at what happened to durable spending, we got an opposite sign. So we got that when people raise their inflation expectations, the durable spending, the probability of them purchasing a durable good actually went down, which I'll come back to in a bit. Okay, but this is basically kind of the whole strategy. Right? So you measure the beliefs, you do an information treatment, generate exogenous variation in beliefs, and then you track to what extent that affects ex post decisions. Okay, so I showed you one example for how inflation expectations affect spending. People have been applying this to all kinds of different topics, not just on inflation expectations, but also on how uncertainty affects decisions of firms and households. People have looked at exchange rate expectations, housing price expectations. You can look at returns. I think it's that one, or is it me? No. All right. Yeah, so conceptually, you can apply this anywhere, right? Anywhere people's expectations of the future should matter for their decisions, you can do this kind of experiment. Okay, hopefully I made the experiment sound really simple. So now let me kind of describe a subset of the issues that arise when you do this. Paul, can you remind me how much time I have?
Yeah, you have till 12.
3 minutes. Okay, all right. So as I mentioned before, right, to measure the expectations, you're going to have to do a survey. So all of the issues that arise with surveys are going to arise here. The one caveat to that is the one that I mentioned before, because ultimately you're going to be doing some kind of diff and diff. You're going to be netting out a lot of the level effects that can arise from question formulations. So these results will tend to be less sensitive than typical survey approaches, but still you have to worry about all the usual survey things. Okay, the second issue you're going to run into is where can you actually do this? Most surveys do not allow information treatments to be implemented. You can't do this in the Michigan Survey of Consumers. You can't do this in the New York Fed survey. You can't do this in most surveys of firms. So there's a lot of limitations in terms of which surveys you can actually will allow you to do this. One option is doing your own online surveys. There you're kind of unrestricted, but that can be pretty expensive. If you want to do your own survey of firms, that's going to be really, really expensive. So that's a challenge that people run into. And the third one, which I just kind of breezed over, is you need the information treatment to work. In the example I showed you, the treatment was very powerful. It turns out, I think it's probably just me over here. It turns out there's no guarantee of these treatments working.
Ollie, do you think we should just go back to holding the microphone and try to
Should I turn this one on? Yes. Okay. Yeah, so you have to get the information treatment to work. And it turns out in many cases, that's not going to happen. And in fact, in many cases, you would expect information treatments to fail. Right? So one way to think about it is, imagine that we were in a full information rational expectations world, just like in our traditional models, right? If you tried to do an information treatment there, it would fail because the information you would provide would already be known to the agents, right? So this approach relies on there being some kind of inattention, some kind of imperfect information, so that you can provide new information to agents. But when people are choosing, what to be attentive to, how much information to collect, right? What they're going to do in general is they're going to say, look, for each decision, I'm going to ask myself, what information is really important to me? And that information I'm going to be well informed about. I'm going to choose to pay attention to. Okay, so it's going to be very difficult to actually change people's beliefs about the expectations that are most relevant to their decisions. Because for those decisions, for those expectations, they're going to choose to be well informed about. Okay, so an extreme case of this is, suppose you're planning to buy a house, right? So you're going to make this one very big decision, right? Well, you're probably going to choose to get a lot more information about interest rates, inflation, and so on than the average person, right? And so it's going to be very difficult for me to be able to change your beliefs about those things when you've become very well informed. Okay, and I'll show you some examples of this. You have to be able to measure the outcomes. So the Nielsen, this is a great case where you can actually have external information on people's decisions. A lot of the time that's not available. So then you have two alternatives. One is to go back to people and ask them ex post, what did you do? So you get self-reported decisions. Another option is at the end of the survey, you ask people about their plans. What do you plan to do? And so you can assess whether an information treatment led to a change in the planned decisions of agents. That's not going to be as good as having the ex post outcomes, but that's one thing you can do. Number 5 is what I'm going to talk about in more detail. External validity. You know, if you ever do one of these RCTs and you present it to a macro crowd, usually the first question you're going to get is, you know, great, you did this experiment in one place at one moment in time. What does this tell me about every other place and every other moment in time? Okay, and that's a great question. You know, we should always worry about the external validity of these things. And so there's really two solutions, two responses to that. So one is you have to redo these things at different times in different places, right? That's one way to assess the external validity. If I repeat the experiment multiple times, do I get the same thing? And I'll show you an example of this. The other thing to think about with external validity is you have to ask yourself, do I expect this result to hold necessarily in other settings? And the answer to that is going to depend on what you're estimating, right? So if you think what you're estimating is a structural parameter, then the answer should be yes. Okay, if I replicate this anywhere else at any other time, I should get back the same structural parameter. If what I'm estimating is the reduced form parameter, which is capturing different channels, et cetera, then no, not necessarily. So given all the things that can kind of go wrong, it'd be great if there was some simpler and cheaper alternatives to this. If there's time, I'll talk about one alternative at the end of this. And then the final thing you should always worry about you know, is going from partial to general equilibrium. Everything we're going to estimate here is a partial equilibrium object, right? So you don't go from these to making general statements about what's going to happen at the aggregate level, right? This does not solve that issue, so you're still going to need a model to go from these estimates into making statements about aggregates. All right, so what I'm going to focus on brief for a little bit here is how to interpret these estimates, direct versus indirect effects. Okay, so one way to think about this is with price setting. So Yvonne Werning had this paper kind of going to this question of how do inflation expectations affect firms' price setting decisions? Okay, and he said, well, you can't answer that question by looking at a Phillips curve. Because the Phillips curve kind of embodies a whole bunch of assumptions. By the time you get to the Phillips curve, you've imposed a whole bunch of assumptions that impose restrictions on the expectations process. Says instead what you have to do is really start with the problem of a firm that's trying to set its prices, right? Its price, if it's a sticky price firm, there's really going to be two things that matter for its decisions. One is current and expected marginal costs, right? He lumps all of that into the A term. And the other thing that's going to matter is inflation in the future, right? Because if you choose a price today that you're going to be stuck with for a while, that price is going to fall relative to your competitors over time. Your relative price is going to change, right? The faster you think it's going to fall, so the more inflation you think there's going to be, the higher the price you need to choose today. Right? So that's the pi e term. So when you average across firms, the average price change, pi t, should depend on both that expected inflation term and the marginal cost. Right? And so when you do an RCT, what are you going to identify? Right? So the kind of the thought experiment I was giving you is let's generate exogenous variation in pi e. Let's look at how that affects, say, firms' prices, right? So that's going to be the pi t term. And then the question is what we're identifying, is it going to be this direct effect of inflation expectations? And the answer is not necessarily, right? Because imagine that I give the firm information that changes their inflation expectations, and suppose that it also changes their beliefs about what's going to happen to their marginal costs. Right? Well, then their prices are going to change for two reasons, right? Both the direct effect of, oh, my relative price is going to fall faster over time, but also because potentially you think your marginal costs are going to change differently. Right? And the RCT is going to lump all of this together into one parameter, one estimate. Right? So I have to ask, well, which parameter, which of these do I actually care about? Do I want the total effect, or do I want these partial effects? Again, the question is, it depends, right? If you're a policymaker, to some extent, what you really care about is the total effect, right? If you're asking the question of, suppose inflation expectations goes up, what's going to happen to inflation? Right? You don't really care so much about the different channels. You just want to know, what is this total effect? Right? If you're a macroeconomist and you're trying to figure out these different channels, right, then you want to be able to separate between these things. So let me give you an example of how you can do that. Okay, and the trick is basically going to have different information treatments. So with different information treatments, you can generate different changes in inflation expectations, and in this case, beliefs about marginal costs, in such a way that you can separately identify those two things. Okay, now the application is going to be going back to the effects of inflation expectations on consumption. So this experiment that I was describing before, but here the margin that we're going to try and separate out is the effects of uncertainty, so the second moments, separately from the first moments. Okay, and the reason why we're worried about second moments is this feature of the data, which is this is a cross-section of households in the euro area. If you look at their inflation expectations against their inflation uncertainty, right, you get this very striking positive correlation. People who anticipate higher inflation tend to be more uncertain about that inflation. Right? So then you think about the RCT that I described, right? We're lowering people's inflation expectations. What that means we're probably doing at the same time is reducing their inflation uncertainty. Right? And uncertainty should matter for your consumption decisions, but potentially in a way that's very different from the first moment effect. Okay, so what we'd like to try and do is separate out these two effects. Okay, so we tried to do this in an experiment in the ECB survey of consumers. And so we basically followed the exact same structure as what we did in Nielsen, except in this other very large survey. right? So you're going to measure prior beliefs, now including uncertainty. You're going to do an information treatment. You're going to measure posterior beliefs. And then we're going to have subsequent waves of the survey that allow us to track people's spending decisions, their employment decisions, their portfolio decisions, et cetera. Okay. The difference is going to be that in the information treatment, we're going to try deliberately now to affect both the first and the second moments of people's expectations. Okay, so we did this by having 3 different treatments. Okay, and the first treatment is identical to one of the ones that we had in the Nielsen survey, right? And that's just telling people the average forecast of professionals was 2.5% for the next year. The second treatment, what we call kind of the second moment treatment, tells people the difference in forecasts between the optimists and the pessimists amongst professionals. So it says the average difference in forecasts is 3 percentage points. This is basically a statement about disagreement among professional forecasters. Okay, and the third treatment is a combination of the two. Okay, so the goal here is not necessarily to have one treatment that only moves your inflation expectations and another treatment that only moves your uncertainty. Right? What you need to do to be successful is you need the treatments to induce different relative variation in the first and the second moments. Okay, so intuitively, if you go back to this figure, right, what you want is you want one treatment that's kind of moving you at a different slope than this, and another treatment that's moving you at another different slope. Okay, and once you have different relative changes in the first and the second moments, then you're going to have identification. Okay, and so that's what these treatments did, is they generated different relative changes in the first and the second moments of people's expectations. Yes?
Are you worried that the length of these treatments is very different?
No. I mean, to some extent, for what we're doing, it really doesn't matter. As long as it's kind of successfully generating the variation that we want, the mechanics of how you do it is not important. So, you know, we were trying to keep them kind of similar conceptually initially. So one was meant to target more the first moments, the other more the second moments. The last was going to have both effects together. But it doesn't need to be that at all. Right? As long as you're moving the expectations and breaking this correlation differently across treatments, that's all you need. That's all that matters. Okay, so once you run these treatments, right, then we're going to do the exact same kind of regression as before. We're just going to look at outcomes. What did an individual do ex post? And we're going to project it on now their first and their second moment expectations. Okay, so your inflation expectations and your inflation uncertainty, controlling for all the same kind of stuff. And again, the first stage in each case is going to be you take that posterior belief, you project it on treatment indicators, interacted with the priors. Right, so visually, it's going to be the same idea as before. I just want to show you kind of quickly what you get from doing this. So I'm going to show you results for durable goods, because the durable goods is where we had this funny result before, that if you raised people's inflation expectations, we found that people's durable goods consumption ex post went down. Okay, so we had speculated in the first paper that this must be coming from some other expectation is changing at the same time. That's making people kind of more pessimistic and leading them to reduce their durable goods purchases. So here we're going to try and assess that hypothesis. All right, so I'm going to show you what happens separately for people's uncertainty and then their inflation expectations on different kinds of durable goods purchases. Okay, and so looking first at uncertainty, right? What we get is as people become more uncertain about future inflation, they become less likely to purchase any of these durable goods in the next month relative to their prior plans, right? So you kind of get the uncertainty effect you would expect, more uncertainty, fewer durable goods purchases. For the first moment, sorry, I lost it. There it is. You get, if anything, now positive effects. Right? So this is saying, all right, increase your inflation expectations, you go out and you buy durable goods. Right? So I like this result because it kind of speaks, in my mind, to what happened in the U.S. with the tariff announcements. Right? So we have Liberation Day. Right, so Trump announces we have these big tariffs coming. And so how do you think about, future tariffs, right? Well, future tariffs is a future increase in prices, right? So one channel that you have in mind is it's an increase in inflation expectations. What you should do is purchase all these durable goods today, right? Before they become more expensive. Right? And that's what some people did. So I bought a car, I bought a TV, I bought a coffee maker. I mean, you name the electronic good, like I tried to buy it ahead of time. Right? But if you look at spending data in the US, there wasn't a huge surge overall. Right? Why? Well, one explanation is there was a second thing going on, which is at the same time as you have this increase in expected inflation, you have a surge in uncertainty. Right? And what is uncertainty going to do to spending? Right? It's going to tend to reduce spending. Right? So what happens on net, right, depends on the relative strength of these two effects. Right? And what's kind of neat here is if you rerun the regression that we ran before in the previous paper where you just have inflation expectations, right? You don't control for the second moment separately, you're going to recover that same negative effect that we had before. Right? So inflation expectations go up, ex post, people are less likely to buy durable goods, but that's coming from the fact that this higher uncertainty effect is more powerful than the first moment effect. How am I doing on time?
Another
5 minutes. Okay. All right. So let me move on to a second issue that's kind of interesting, which is getting the first stage to work and what happens when it doesn't. Okay. So the first time that we did an RCT with Yuri, it was on firms in New Zealand. We treated them with information about inflation. It worked beautifully. Huge effect on their expectations. We thought, oh, this is going to work like everywhere. It's amazing. And so we found some co-authors in Uruguay where there's an amazing survey of firms, and we ran the same experiment there. Okay, and so I'm going to show you a few figures where on the vertical axis I'm going to show you treatment effects. Okay, and so a zero treatment effect means a zero treatment effect. You did not change expectations at all. Right? More negative numbers, that's going to mean the treatment effect worked. Okay, so in 2018, we ran this experiment on firms in Uruguay, and we got a treatment effect of 0. Right? So we went to these firms, we told them central bank's inflation target in Uruguay, just like we had in New Zealand, and it did absolutely nothing. And we thought, oh, we must have done something wrong, so let's do it again. This time we'll tell them what the inflation rate was. And we got, again, 0 effect. Nothing happened. No effect on these firms' expectations. We tried one more time. Year later, failed again. No. Like, something's wrong with Uruguay. And then, yeah, we weren't sure what to think of it. We kind of missed what was going on. But then in the US, we started repeating the same survey as the one that I described from 2018 multiple times. Okay, so this is 2018 Q2. This is the experiment that I started with. Right, so you can see these treatment effects here, minus 0.75. These are very large treatment effects, right? It worked really well. We did it again in 2019. If anything, even larger effects. Right, so the black line, this is inflation in the U.S. And then we didn't do it for a while. And then we started redoing the same experiment as the inflation rate surged in the U.S. And what happened, you can see, is the treatment effects, they changed pretty dramatically, right? Especially with the treatments where we told people what the inflation rate was. When we were doing this in 2022, the treatment effects were about a third of what they were in 2018. Okay, we were barely having any effect on people's inflation expectations, essentially because people were paying attention to inflation at that point. They knew what the inflation rate was, and so our treatment didn't work. Right? What had happened in Uruguay? Well, Uruguay was a relatively high inflation country. Those firms, they knew exactly what was going on with inflation and the inflation target. Right? They were well informed. The inflation treatments didn't work. Right? So it turns out this was kind of true much more systematically. If we pool across treatments across a whole bunch of different countries over a whole bunch of different time periods. So this is a lot of RCTs all pooled together, right? What we're doing is we're looking at the inflation rate that there was at the time of the treatment compared to the size of the treatment effect, right? What you can see very systematically in high inflation environments, treatment effects are close to zero. People are attentive. Right? In low inflation environments, treatment effects are very large. Right? So attention is varying with the economic environment. Right? And this is important. And I think I'll end with this. It's important for understanding why inflation expectations of households and firms seem to be so unanchored in many advanced economies. We think it reflects what we're kind of loosely calling the cycle of selective inattention, right? Because what happens when inflation is low, as it was in the US in 2018, right? It had been low for a long time. People's incentive to pay attention to inflation is very low. Right? So they're not following aggregate inflation. They're not listening to the central bank, right? They're just going to be basing their expectations off of whatever prices they see when they're shopping, when they're working, right? So those expectations are going to tend to be pretty volatile. They're going to look unanchored. And then you run into a high inflation period like the surge, people start to pay attention, right? They see the inflation rate. They learn what the central bank's inflation target is, right? And what do they learn? At that moment in time, they learn that the central bank is failing. Right? If we go back to this figure, right, when Americans started paying attention in 2022, right, what they'd learned is inflation is 10%, the Fed's target is 2%, right? And the Fed is no good at its job. That's what they learned. Right? So what is that going to do? Well, that's going to further unanchor expectations. Right? So the challenge for policymakers, it's not to try and communicate with the public during this high inflation period, because there, people are attentive, they know what the inflation rate is. You're not going to be very successful at changing their views then. Right? You have to do it when inflation is low and people are inattentive. But at that moment in time, people aren't paying attention. So actually getting through to them is going to be very challenging. All right? But that's the time that you have the scope for actually affecting people's expectations in a meaningful way, right? If you wait for this high inflation period, then it's going to be too late. So I'll stop here.
Can I ask a question at that point? So, is there any way that you can measure central bank credibility objectively? Take something like TIPS, implied inflation or something, and allow for that in your regressions so you can separate out the information effect and the credibility effect?
So the tips, anything coming from financial markets is going to capture the perceived credibility from a very different group of agents, right? So you have to think about households, firms, financial markets separately. You don't want to lump them together, because this logic doesn't hold with financial markets, right? Financial markets are attentive all the time. Right? This is a story about households and firms. So you can measure central bank credibility in the surveys for households and firms and try and control for that. But that's often not available. But, yeah. So I think I'm out of time. So I'll stop on this note. So thank you very much for your time and attention. I appreciate it.
Questions? Any questions?
Wouldn't you expect there to be a difference between firms and households in, the knowledge they have of inflation? So a lot of you said you had the households for the Nielsen, the other one was with firms, but you were kind of putting them all together to see the effect of them.
Yeah, and you do see differences. So when you have surveys of firms that you can compare to surveys of households, they are going to look different along some metrics. What's pretty striking though is that most of the time firm surveys look a lot more like household surveys than they do surveys of professional forecasters. So if you want a proxy for the firm's expectations, the better proxy is the household expectations, not the professionals. But that doesn't mean that their expectations are going to be the same as the households. There will be some important differences at times. Yeah.
Thank you. Obviously, it's very important to differentiate these three groups in terms of expectation formation. I wonder, though, what would you do now in terms of using your estimates with regard to inputs in a, say, DSGE model? What type of expectations would you use? Would you use all three? Would you weight them? How would you go about including these expectations in these models?
Well, I mean, in a DSG model, you have very well-defined agents, right? You have your consumers, right? And you can model their expectations process. You're going to have your firms, they're forming their own expectations. You can model that expectations. You have financial markets, you can model that expectations, right? So there's no reason to impose from the get-go that they all have the same expectations the way we typically do. Right, it's not a challenge per se in the model to allow for there to be different beliefs across those agents.
But I mean, you would expect some sort of interaction within the general equilibrium framework.
Absolutely, sure.
That you have these sort of separate expectations running in parallel.
Yeah, no, there will be interactions in general equilibrium. Absolutely, yeah. Yeah, so here, we're not saying anything about those interactions, right? We're treating each of them individually in partial equilibrium, right? To make general equilibrium statements, you have to put that into a model and see what that interaction will do.
Yeah, really interesting. I wanted to ask about the effect of inflation expectations on household spending. So my understanding is that the first moment should have a positive effect, the second moment should have a negative effect. But does it also matter whether it's like based on a demand or supply driven shocks? So like say tariff shocks versus more like expectations of a boom?
Yes, in general, absolutely, right? So, if you think that the households are, as they change their inflation expectations, if they view inflation as an endogenous object, which is a function of underlying shocks, they're going to have to take a stand on what they think is driving that process. If you think it's a demand side shock, then you might also think, oh, this is going to increase my income, et cetera. So those channels are going to have positive effects on your consumption. If you think it's a supply side shock, then it could do the opposite, right? So that's going to be part of the indirect effects that can matter for how the decision ultimately is affected. Right? So in principle, you want to be able to separate out those different effects to the extent that you can. And in certain cases, that seems to be very important. So, for example, we looked at how firms in Italy responded to changes in their inflation expectations. And there we found that the firms most of the time had a very supply side driven view of inflation. And so when they raised their inflation expectations, they tended to become much more pessimistic about the economic outlook for their firm, and they cut employment, they cut investment, et cetera. And then at the ZLB, it was very different. When they raised their inflation expectations, they had a very positive view of the economy, and so then they reacted very differently to that change in inflation expectations. And so, yeah, the broader interpretation that people take and the extent to which that's going to affect other expectations is going to matter for the total effect on decisions, right? Which captures all these different channels.
Hi. So over time, central banks are always communicating with the public. They're making statements. The chairman speaks. Members of the board speak. These are, in some sense, all treatments on the public that are taking place. They're not taking place in your type of controlled environment, but they're still treatments. And your experiments, I'm thinking in particular the case you described in New Zealand, the fact that you are getting an effect there tells you something about the communications of the central bank. The treatments that they're performing weren't working, right? So what do you take from your results about how central banks should be communicating with the public? Because it would appear that they're often failing.
Yeah, thanks for that question. So yes, that's exactly how we would characterize these results. Is saying that the fact that the treatments are so powerful in these low inflation settings is a reflection of, in part, of the fact that central banks are failing to get that information out there in the first place during those environments. So how could you do better? Right. And again, the challenge is in this setting, people are not listening to Powell's press conference. Right? They're not reading the newspaper to find out what the central bank is doing. They're not keeping up with the latest inflation news. So you have to find non-traditional ways to reach people, or much more direct ways to reach people. Right? You can't rely on sending out a message and hoping the news media is going to transmit it to everyone in a way that's going to reach people, because it's not reaching people. So how do you do it? I mean, it's not rocket science. Politicians have figured out how to get messages to an audience that doesn't necessarily want to hear from them. Public health officials have figured out how to get messages to an audience that doesn't necessarily want to hear from them. Corporations have figured this out. So there's a wide range of strategies that central banks could use that would likely be much more successful than speaking to reporters and hoping, that's going to magically transmit to a population that's not interested or that has bigger problems to worry about at the moment. Yeah, so I don't know, examples. Think of like the public health campaigns against smoking. Like, how did it work? It was basically billboards for 20 years with horrible pictures, smoking kills, and that's it. And you repeat the message over and over in every medium that an individual is going to be exposed to. Central banks can do something very similar. Take a billboard. Inflation has averaged 2% over the last 30 years, thanks to your local central bank. Boom. It doesn't have to be complicated. Yeah.
It's just a very quick snippet here, but if you had a billboard that said inflation's been 2%, they still wouldn't listen because it doesn't matter to them. Right? If inflation is 1.5%, yeah, so what? Thanks. It's completely, it's low. It's like breathing air is good for you. Okay. But when inflation gets 10% or 11%, remember once driving to work and we got a generous payoff for 2.5%, I think was the news, and the other news was inflation was 11%. That makes everybody pay attention, even in the Department of Sociology or something.
No, again, this is the challenge. Is during the low inflation time, people they're not motivated to pay attention. They have other things to worry about. So but that's still the time to get the information to them, right? That's the time where you can actually anchor their beliefs in some way. So you just have to find ways to do it. And people are still acting on those beliefs during those periods, right? So the evidence from 2018 that I was showing you for how consumers respond to their inflation expectations, that's from the low inflation era, right? They responded to the change in their expectations. It's just when you're thinking about a decision, there's just you have a list of things that are relevant to you, right? There's like first order things, and then there's second order things, and most of us don't have time to get to the second order things. But if you get that information for free, it doesn't mean that you're not going to change your decisions in response to that information. And so, I think it can still work, but that's the challenge: is how do you get to those people when they're not seeking out the information themselves?
So there's somebody right at the very back, and there's somebody just taking the text.
Thank you. So, I get the distinction between the attention and high and low, but how does it relate to stable versus more volatile inflation? Because there's typically we have also very little volatility in the inflation rate to start with. And so when it's high, is that part of the story that inflation can become more volatile? So that was question one. And question two I had was when we look at household behavior and spending and how sort of inflation expectations affect household spending, how is it connected to wage inflation expectations? Because, in a very simplistic world, it doesn't matter. Well, it does matter. But if my real income is sort of unchanged, then this has a very different effect than if I see my real income being deteriorated. So if you could elaborate a little bit on that, would be great. Thank you.
I can try this again.
Yeah, good question. So, on the first point about the uncertainty, yeah, high inflation is volatile inflation. And I think that's part of what's driving that correlation that I showed you, right? In the cross section, you see when people expect high inflation, they're much more uncertain about inflation. That's a very reasonable kind of thing to observe. and then trying to separate out those effects. Again, that's what we were trying to do, but it requires breaking through that strong correlation. The second question, on the wage expectations. Yeah, absolutely. I mean, in principle, right? It's your real wage that should determine things. In practice, people don't revise their beliefs about their own income very much when they change their inflation expectations. So they see almost no pass through of aggregate inflation into what's going to happen to their wages. And so, these are changes in perceived real wages that you see. Yeah.
Thank you very much for your talk. I just want to follow up on the comparison between medical RCT and your RCT here, because in the medical RCT, if someone receives COVID vaccine in the treatment group, that person definitely received the treatment. If someone does receive the placebo, that person definitely does not receive the treatment in the control group. So just mimicking the case here, let us say if someone does not receive the information in the control group, that person can easily go to TV or newspaper to get inflation forecasting, or even that person can check something like a survey of professional forecasters, which is publicly available, to get those information. On the other side, if someone receives the information in the treatment group, and you can argue that that person is not burdened to watch TV about inflation news, why that person is burdened to look at the information you have provided in your survey. So it seems that there is a contamination, if I can use the word, between control group and the treatment group, comparing to the medical study. If I may, can I please check with you, is this kind of limitation here? Thank you.
Okay, we've got one more question here, and that will be the last question of the session.
Yeah, I'll answer in the meantime. I mean, conceptually, yeah, it could be an issue, right? So if I give one person the information, and then that means that they're not going to go out and pay attention to the news, whereas the person in the control group does get the news. Ultimately, they have the same information. They're going to act the same. I'm going to say, oh, look, they're so different after the treatment. But what you can do is, if you track people over time, if you track their expectations over time, you'll see that it's not just at the end of the survey that their expectations are different. A month later, their expectations are still very different. So, it's not like the control group is going out, watching the TV, getting the information that the treatment group got, and so that they end up, the same. So that just doesn't take place. If it did, it would be a problem, right? But in practice, it doesn't seem to hold. Yeah.
Do you have any evidence of a different heterogeneous response of households to inflation expectations? Because this may be first order in terms of distributional effects of monetary policy. So like maybe wealthy individuals, they respond and they optimize with respect to inflation expectations, whereas, poorest individuals basically do not, or much more sticky.
Yeah, that's a great question. And so that brings us to kind of another limitation of these things that I didn't have the time to talk about is it's actually pretty difficult to be able to speak to heterogeneous effects of beliefs on decisions because the sample sizes and kind of the noise and the data really makes it very difficult, right? So even when you start with 20,000 people, you split it into a bunch of treatment groups, and then you've got to be able to go back to them later, and so you lose a lot of people there. and then you've got noise in the expectations, you've got noise in the self-reported outcomes. And then if you have to split your sample into subgroups to look for different effects of the expectations, that's usually where the noise just kind of dwarfs everything. And so most of the time when we've done this, we've found very little evidence of heterogeneous effects in terms of how the expectations affect decisions. We can't reject the null of equality most of the time, but we suspect that that's mostly a power issue and not the fact that everybody is responding in the same way. We don't have the ability to separate it.
Great. Well, thank you very much, Oli, for a really interesting lecture. And the number of questions reveals that we're super interested in what you have to say. If you didn't get a chance to ask a question, buy the book. It's probably the answer's probably written in there. So, and Oli didn't ask me to say that. Thanks very much. Thank you.